Bismillahirrahmanirrahim. Assalamu alaikum. In this video, we shall find the center of mass of a lamina. Lamina is a thin plate. If we are given two functions, f of x and g of x, such that f of x is greater than or equal to g of x, then from these two functions, from x is equal to a to x is equal to b, we can generate a thin plate, which is called a lamina. And now the task is to find the center of that lamina. To find the center of the lamina, we need the x coordinate and y coordinate, x bar and y bar. So center of mass is equal to x bar comma y bar. Now how to find x bar? X bar can be obtained by this formula. Here A is area between the two curves, and y bar can be obtained by this formula. Again, here A is the area between the two curves. So the area formula is integration from a to b f of x minus g of x dx. To find center of mass x bar and y bar, the first task is to find the area. Then you can find x bar. So in x bar, you should use the value of a. Then you can find y bar and y bar in this formula. You should use the value of a. And then you can put x bar and y bar in star, and that will be the required solution. Let us see how we can get these formulas. The first formula is to obtain the x coordinate x bar. So let us consider this figure in which we have two functions f of x and g of x, and we can see that f of x is greater than or equal to g of x for all values of x belongs to a, b. Now area of the region between these two curves from x is equal to a to x is equal to b is integration from a to b f of x minus g of x into dx. To find the density, we know that density rho is equal to mass per unit area, and from this we can get that mass is equal to rho into A. And if we put the value of A, we have m is equal to rho. Integration is from a to b f of x minus g of x into dx. Now, moment about the y-axis. That is equal to mass into displacement from the y-axis. Look at this figure. Now, displacement from the y-axis is x. So, my can be obtained as my is equal to m, where m is rho. Integration is from a to b f of x minus g of x into x dx. And now to find the x coordinate x bar, that is equal to moment about the y-axis divided by mass. So let us substitute the value of my, which is equal to rho. Integration is from a to b. Let us write x here, and to f of x minus g of x dx divided by m. And we know that m is equal to rho into a. Now rho will cancel with rho, and we get x bar is equal to 1 over a. Integration is from a to b f of x minus g of x, and x is also here, into dx. So that is the first formula which we get by using these calculations. Now let us find the y coordinate of center of mass. Consider the same two functions f of x, which is greater than the g of x for all x belongs to a comma b. And now the area between these two curves from a to b is given by this formula into dx. Now the task is to find the y coordinate of center of mass. So in the first case, we need rho, which is density, equal to m over a. And from here we get m is equal to rho into a. And now if we put the value of a, which is from a to b, f of x minus g of x dx, we get that thing. The next thing is to find moment about the x-axis, which is equal to mass into displacement about the x-axis, because this is moment about the x-axis. So let us consider a small rectangle, and we need to find this distance, which is, let us say, y. Then we can obtain that y is equal to f of x plus g of x divided by 2. So let us use these values. We have mx is equal to m is rho, integration is from a to b, f of x minus g of x. And to y, the value of y is f of x plus g of x divided by 2. And from here, now we can get that mx is equal to rho by 2. Integration is from a to b, and we use the formula a minus b into a plus b. According to that formula, we get f of x square minus g of x square into dx. And finally, to find y bar, that is equal to mx divided by m. Let us use the values. We have rho by 2, integration is from a to b, f of x square minus g of x square into dx divided by m. M is equal to rho into a. Now rho will cancel with rho, and from this we can get y bar, which is equal to 1 over 2a. Integration is from a to b, f of x square minus g of x square dx. That is the required y coordinate of center of mass. Let us see an important summary. If we are given a question in which the density is constant, it means a rho must be equal to some constant, just like 2, 3, 4, 1 over 2, some real number. In that case, center of mass will be equal to x bar comma y bar, and we can obtain x bar by using this formula, y bar by this formula, where A is area can be obtained by this one. But if we are given a question in which the density is not a constant, it means density rho is equal to some variable. Rho is equal to some function of x. Rho is equal to x. Rho is equal to x plus 1. Rho is equal to x square. In that case, center of mass is same, x bar comma y bar. But now x bar is equal to 1 over m, and rho integration from a to b rho into x f of x minus gx. Y bar is equal to 1 over 2m. Integration is from a to b rho f of x square minus g of x square into dx, where m is integration from a to b rho into f of x minus g of x dx. However, these formulas can be used even if rho is constant. For both cases, you can use these formulas, but the first one can be used only if rho is a constant. In example number 1, we are given that density is constant, which is equal to 3. And here we can see that under root x is greater than or equal to x for all x belongs to 0, 1. So we take f of x, which is equal to under root x, and g of x is equal to x. The first task is to find area, which is given by integration from a to b f of x into g of x dx. And if we plug in the values, we have integration from 0 to 1 x power 1 over 2 minus x dx. So let us integrate this. We have x power 1 over 2 plus 1 divided by 1 over 2 plus 1 minus x square divided by 2. Limits are from 0 to 1. And from here we get x power 3 by 2 divided by 3 by 2. So it will become 2 by 3 minus x square divided by 2. The limits are from 0 to 1. Now if we put the limits, we have 2 by 3 into 1 minus 1 over 2 minus 0 in minus 0. So the next term is 0. We don't need that one. And if we simplify this, we get a is equal to 1 over 6. So that is the required area. Now to find the x coordinate of the center of mass, we know that x bar is equal to 1 over a. Integration is from a to b x into f of x minus g of x dx. Let us use the values. We have 1 over a is 1 over 6. Limits of integration are from 0 to 1, x into x power 1 over 2 minus x dx. From this we get 6. Integration is from 0 to 1. x power 1 over 2 plus 1, this is 3 by 2, minus x square into dx. Let us integrate this. So we have 6, and now this is x power 3 by 2 plus 1 divided by 3 by 2 plus 1 minus x cube divided by 3. The limits are from 0 to 1. So from this we get 6 into x power 5 by 2 divided by 5 by 2. So it will become 2 by 5 minus x cube by 3. Limits are from 0 to 1. Let us put the upper limit and then the lower limits. So we have 2 by 5 minus 1 over 3, and if we put the lower limit we get 0. And now let us simplify this. So if we simplify this, we have x bar is equal to 2 by 5. Now let us find the y coordinate, which is equal to 1 over 2a, integration is from a to b, f of x square minus g of x square into dx. Let us use the values. 2 into a, the value of a is 1 over 6. Integration is from 0 to 1. F of x is under root x square is x, minus g of x is x square is x square into dx. Let us simplify this. From this we have 3 limits are from, okay, let us integrate it now. So we have x square by 2 minus x cube by 3. The limits are from 0 to 1. Let us substitute the limits. So we have 3. The upper limit is 1. So we get 1 over 2 minus 1 over 3. And if we substitute 0, we get 0. And now from simplification here we get y bar is equal to 1 over 2. So that is the y coordinate. Now the final answer, center of mass, that is equal to x bar comma y bar. So x bar is 2 by 5, and y bar is 1 by 2, and that is the required solution. In this example, we can see that density is a variable. We can also find that x is greater than or equal to x square for all x belongs to the interval 0, 1. So we take f of x equal to x and g of x equal to x square. Now the first task is to find the mass, which is given by integration is from a to b, density into f of x minus g of x dx. Let us use the values. A is 0, b is 1, rho is x, and f of x, that is x, g of x, that is x square into dx. And if we simplify this, we get x square minus x cube into dx. Let us integrate this. So we have x cube divided by 3 minus x4 divided by 4. limits are from 0 to 1. Now we use the limits. If we put 1, we get 1 over 3 minus 1 over 4. And if we put the lower limit, we get 0. So if we simplify this, we get m is equal to 1 over 12. The next task is to find x bar. So x bar is equal to 1 over m. Limits are from a to b, rho into x, f of x minus g of x dx. So we can find, putting the value of m, which is 1 over 2, so we have 12 here. Limits are from 0 to 1. Rho is x, and here we have another x. F of x is equal to x, and g of x is x square. So let us simplify this. We have 12. Integration is from 0 to 1. X into x is x square. Let us multiply x square. So x square into x is x cube, minus x square into x square is x4 into dx. And now let us integrate this. So we have x4 by 4 minus x5 divided by 5. The limits are from 0 to 1. And now we can get that x bar is equal to 12. If we use the upper limit, we have 1 over 4 minus 1 over 5. And if we use the lower limit, we get 0. So if we simplify this, we get x bar is equal to 3 by 5. And now let us find y bar. So y bar is equal to 1 over 2m. Integration is from a to b, rho into f of x square minus g of x square into dx. Now putting the values, we have 1 over 2 into the value of m is 1 over 12, so we can write 12 here. So this is 12 by 2. Limits are from 0 to 1. The value of rho is x. Now f of x, this is x, so x square here, and minus g of x is x square square is x power 4 into dx. Let us simplify this. We have 0 to 1. Now this is x cube. This one is x power 5. And from here, if we integrate this, we have 6 into x4 divided by 4 minus x6 divided by 6. Limits are from 0 to 1. Now let us put the limits. So we have 1 over 4 minus 1 over 6, and if we put the lower limits, we get 0. So from this we can get that y bar is equal to 1 over 2. Hence, center of mass is equal to x bar comma y bar. Let us put the values. So we have 3 by 5 comma 1 over 2, and that is the required solution.